to product rule, and we're going to be talking about integer exponents, and then the little to do with section 4.2 is scientific notation. So what we have to do for the product rule is anytime we have same bases, so right here you can see we have a and a, we're going to add the exponents. Okay, so let's do that with some examples. All right, so for letter A, you want to note that we have the same base of 8. So we can write 8 to the 5 plus 4, which is really the same as saying 8 to the 9th. Now we know that 8 to the 9th is a real number, but we are not told that we have to evaluate here, so we can leave it as 8 to the 9th. For B, you want to notice that you have the same base of 4. So we can do 4 plus the 4 raised to the 1 plus 2, which is also the same as 4 cubed. Okay. C is 3 different items here. We have r to the 7th times r to the 1st times r to the 9th. You can see they're all r's as our bases, so we're going to do r to the 9th plus 1, which would be 10, plus 7, which would be 17. So r to the 17th. Now, what's interesting about D here is we have P and Q. Okay, we have P squared, sorry, not plus, times Q squared. So you can use it with the dot. You could also just go like that. Because what you need to realize is that P and Q are different bases. So that's it. You can also say product rule does, not giving them medicine, does not apply here. Okay. So last one is E. So it's going to be 5 times negative 7 times x to the 4th times x to the 1st times y to the 7th times y cubed. All right, so this part here we can do like normal. It's negative 35. Here we have the same bases, so we're going to add the exponents. This will be x to the 5th, and then the same thing with the y's, so y to the 10th. All right. That is the first part. Okay. All right. So what we're going to look at now is the zero exponent rule. If a is any non-zero real number, then a to the 0 is equal to 1, always. So what we have here is you have to be careful of your parentheses, okay? So a says 5 to the 0. Well, that is 1. But B doesn't have parentheses. It just says negative 5 to the 0. Well, we just found out that the 5 to the 0 is 1. So that's actually going to be negative 1. C, we have the parentheses set now. So again, we're back to just 1. D is important because we're getting told this right here. That's important. So, because remember up here, it says any non-zero number. Okay, so it can't be 0. Again, though, we have exponents, or not exponents, we have parenthesis sets with our exponent outside. So it doesn't really matter, no matter what. Each of those pieces is going to be 1. So your answer is 1. Now, E is a little bit interesting. E says 10 to the 0. Well, we know that's 1. Minus 9 to the 0. Well, that's also 1. So then the answer is actually 0. But it has nothing to do with the 0 exponent rule. It just has to do with how we evaluate it. Okay. All right. This one is the negative exponent rule. It's more of like a rule of convention. Okay. So basically it's saying people don't like negative exponents. So we're going to give the people what they want. They want positive exponents. If we have a 9 and a negative to the negative 4th, 9 is any number is always over an understood 1. And the way I look at this is, okay, so here's your a to the negative power. It's under 1. They just flipped the fraction. Okay, they took the reciprocal of it. So that's all we're going to do. When we send it downstairs, it becomes positive. So that's it. That's what we do. Okay. You can see that I'm not going to put the exponent of 1 there because it's understood, just like the 1 underneath is understood. Now be careful here. The negative 6 is going with the whole parenthesis set. So we will have to move everything. And since we have a variable on the bottom, y cannot be equal to 0. Okay, so that would be the whole answer there. That whole piece. Okay. All right. D has no parentheses, so you have to pay attention here. We actually only need to move the part with the negative exponent, so that'll be the k. So negative 4 is going to stay on top. K cubed is going to the bottom. We have a variable on the bottom. We have to tell them that it cannot be 0. Okay. That is that so far. Any questions you'll have to bring to the review? Okay. So this is just saying it again, just a little bit differently, because what we also need to pay attention to is if we have a negative on the bottom, then we would fix it by bringing it to the top. Okay. Okay. And then it also says to evaluate. So even once we get it in the right form, we then have to answer it. So let's look at A here. So 4 to the negative 1 plus 6 to the negative 1. Well, that's the same as saying 1 over 4 plus 1 over 6. The least common denominator, lowest common denominator between 4 and 6 is 12. Okay, so 4 goes into 12, 6 goes into 12, and they don't go into anything else nicely between that. So to go from 4 to 12, you multiply by 3. So we're going to multiply the top by 3 and the bottom by 3. But for 6, it's twice. So you're going to multiply the top by 2 and the bottom by 2. So you're going to get here. You're going to get 3 over 12. Sorry, guys. 3 over 12 plus 2 over 12. And that's going to give you an answer of 5 over 12. Okay. B is more like this second one here, okay? So take a look at that right there, the one that I wrote. Okay, negative underneath to the top. So 1 over 5 to the negative 3, that's going to become 5 to the third. And that equals 125. Okay, 5 times 5 is 25. 25 times 5 is 125. Sorry, I just want to make sure I get this nice for you. Okay, and then C is very similar to B. Okay, we have 10 to the negative 2 over 2 to the negative 5. Well, we're just going to flip their spots. Okay, so 2 is going to come up top with a positive 5 now, and 10 is going to go to the bottom with a positive 2. 2 to the 5th is 32, and 10 squared is 100. Both can be divided by 4, so you end up with 8 over 25. Okay. Okay. All right, special rules for negative exponents. All right, this is the one we've been doing the last 2 sections of it, 2 little sections. This is interesting. We kind of just did it with this one down here with C. Okay, so what we did is, remember, we had 10 to the negative 2 over 2 to the negative 5. And we just flipped them. We brought it to be 2 to the 5th over 10 squared. So that's exactly this type right here. Okay, so let's go ahead and look at let's look at A. Okay, so A says t to the 8th over t squared. Okay, well, quotient rule, let me show you the quotient rule real quick. I think I was supposed to flip-flop these, but I didn't yet. Quotient rule, look at this. We have the same base, and then we subtract the exponents. Okay, let me just go ahead and change that right now for you guys. There we go. All right, let's get back to it then. So you can see here that we have a division or a fraction. So we're going to say, and they're both t's. So we're going to say t to the 8 minus 2 is going to be t to the 6th power. Now we no longer have to worry about the statement here because t is no longer on the bottom of the fraction. Okay. All right, let's work for b. b is 4 to the 5th over 4 to the negative 2. If we follow our definition for division, then we would do 4 to the 5th minus a negative 2, which ends up being 4 to the 7th. Okay, there's a few ways to do that one, so you can play around with it if you want. All right, c is 2 cubed over 2 to the 7th. Again, if we follow the quotient rule, we would end up with 2 cubed minus 7, which is 2 to the negative 4th, but we don't like negative numbers in our exponent spots, so it's going to be 1 over 2 to the 4th. Okay, what you need to notice about D, we still need the n not equal to 0, because if you look, m and n are not like bases. They are not the same bases. So what we say for D is we say we leave this. Okay, that stays. And we say additionally, quotient rule does not apply unlike bases. Okay, that's why they don't apply. All right. All right, power rules. Okay, here's what we got to look at. When we take a power to a power, we keep the base. We're going to multiply those exponents. All right, when we have a parenthesis set and an exponent on the outside, we're just going to distribute it up in the exponent spots. Okay, the same thing with a fraction. You're going to distribute into the fraction, but in the exponent spots. Okay, again, if you have a variable on the bottom, you must say that statement. All right. Okay, let's work some problems. A says x to the 4th squared. So that's the same as x to the 4th times 2. We can make those in a parenthesis set to help you out. No, not periods. So 4. Wow. Apparently I'm just drawing whatever I want right now because it's pretty late. 4 times 2 equals x to the 8th. All right. B, we're going to distribute in. Okay, it's n to the x cubed. I'm going to take that cubed root and give it, or that cube and give it to the 9 and to the x. So we're going to have 9 cubed x cubed. But we actually get to simplify this first part. And if you use your calculators, you'll find 9 cubed is not a normal one that we have memorized, but it's 729 x cubed. Do not try to type in your x into your calculator. You will end up getting an error, or it'll ask you to store it. You don't want to do that. All right, so this is what I mentioned in class, if you were there. If we have an even exponent, the negative will become a positive. Okay, so think of it this way. If we square something, okay, if we square a negative 2, square it. That's -2 times -2. The negative is a positive, so it's a +4. All right. Now let's look at it with a -2 cubed. Well, that's -2 times -2 times -2. We already know that -2 times -2 is +4, but we have a -2. So that means -8. So even exponents, what's our takeaway? Even exponents positive. Okay. Odd exponents when you have a negative sign. Negative. Okay. All right. So let's finish up with C here. So -2 to the 4th power, m3 times 4. Well, -2 to the 4th power would be one more -2 times 8. So that's going to give us a +16. And then it's just going to be m to the 12th. Okay. D. So for D, we're going to take this cube, and it's going to go to each piece, to the 3, to the x already squared, and to the y already cubed. So it's going to be 3 squared times x to the 2 times 3 over y to the 3 times 3. So our final answer here is going to be 9 x to the 6th over y to the 9th, with y not equal to 0. Okay. Okay. Oh, my apologies. I did 3 squared. I did 3 squared because I wrote a little bad here. That's just cubed there. So that would be 27. Okay. Okay. Special rules continued. So again, A and B here cannot be 0. And it's just kind of telling us some stuff we already knew, except it's focusing kind of on this right here. So that we already knew, but not only can we bring it and make it a fraction, we then bring it outside. And then if it is outside already, we flip the inside fraction, and that will make the outside exponent positive. So what we want to do for A here, there's a couple of different techniques you can use, so you can explore those. But if we follow this rule right here, if we follow that for A, use for A, then we would flip the fraction. So it'd be 3 over 1 and square it. Basically 3 squared. So that equals 9. Okay, we do have to evaluate it. B now, we're going to do the same thing. Use for B. All right, so we're going to flip that fraction because it was 5/3 -3. We're going to make it 3/5 to the 3rd, which makes it 3 cubed, which we know is 27, and over 5 cubed, which we know is 125. So 27 over 125. That one's easy peasy. All right. Last one. Well, not last problem. Last one on this page. So now we got to do the same thing. We're going to use this for C as well. So we use that one for all of them. Okay. I'm just going to say focus on this. Okay. All right. So 3 over 2x raised to the negative fourth. We're going to flip the inside, so it's going to be 2x over 3 raised to just the fourth. And now we're going to bring it in. So 2 to the fourth, well, we know that's 16. X to the fourth over 3 to the fourth. So that's 16 x to the fourth over 3 to the fourth is 81. Okay. Okay, almost done, guys. You guys can either pause this on the video or you can get it a little bit nicer off of the power or off the PDF. I would practice these for exam 2. Okay. So let's do some mixing. We don't know what we'll get. So A has all the same bases. Same bases. Check. So that's going to be x to the negative 8th plus 1 plus 4. Well, that gives us x to the negative 3, which we have to do as x to the third on the bottom. All right, B is 5 to the negative third squared. So we can do this either way. We can change the inside or we can distribute. Maybe I'll do it both ways for you. So here we'll flip the inside first. So it's going to be 5 cubed on the bottom. And that's going to be 1 over 5 to the 6th. And it does say to simplify, but I think we can leave that there as it is. We can leave that. The other way to do this one, okay, the second way would be 5 to the negative 3 squared. And then we would make it and multiply that. So it'd be 5 to the negative 3 times 2 would be 5 to the negative 6th. Which would be 1 over 5/6. You can see they're both the same. Okay, let's do C. Actually, let's just do C straight from where it's at. Okay, so again, you have a couple different methods. I'm just going to do one of them. So P squared minus a negative 2, because that's coming from downstairs, right? All right, and then Q to the negative 1 minus a negative 1. All right, so then we'll do it this way. So this becomes P to the 4th on top, Q to the negative 3. So we still got to send Q back downstairs. So P to the 4th over Q cubed. but we're not completely done, because what do we have to remember now? Q cannot equal 0. Okay. P doesn't matter. All right, now D is a little tricky. It's a little bit longer. So let's distribute our outside ones. So that'll be 2 squared x to the 2 times 2 over y to the 2 times 2. Oops, those are cubes. Those are cubes. Sorry, guys. Like I said, getting a little tired. Then we also have -5 to the -2 power times x to the -2 times -2 over y to the first times -2. All right, so let's clean that up a little bit. We're going to have 2 cubed is 8. 2 times 3 is 6, so 8x to the 6th, y to the 6th. Okay, then -5 to the -2 power would be 25, but it's got to go to the bottom. All right, x to the 4th, and then it's going to be y to the -2, so we got to send it upstairs. But we're still not done because we can combine some more of this. So let's go back over here. So that's going to be 8 over 25. The x's come together, so it's going to be x to the 6th plus x to the 4th. Okay. And then the y's actually subtract, but 6 is bigger than 2, so it's going to be y 6 minus 2. So 8x to the 10th over 25 y to the 4th on the bottom, with y not equal to 0. Okay, that is the whole thing. Okay, and that is it for 4.1. 4.2 is on scientific notation. So this is where section 4.2 starts, and it is scientific notation. And if you take a look at this, if you are going from a large number, then you're going to have a positive exponent. If you're going from a decimal, then you're going to have a negative exponent. Okay? So you guys can read that at your leisure. It'll be on the PDF. So let's do A. All right, we have to move the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 7.56 times 10 to the 9th. All right, we want a big number. It's got to be a positive exponent. Next one is a small number going bigger, so we're going to have a negative exponent. 1, 2, 3, 4, 5, 6, 7. So it'll be -7. So -2. Let's make it a nice 2. -2.45 times 10 to the -7th. That's all you need to know for scientific notation for your test. All right, everybody, I'm going to post this, and I will see everyone in class for the review.